day, good morning, or afternoon, or evening, whatever it is for you.
All of the
I said
above.
good day.
Yeah.
Excellent. I'm so happy you're doing this. It dovetails nicely, I think, with the data analysis class Santi's doing for us.
Oh, amazing. Yeah, I would love to tune into that.
Yeah, it's Mondays. We'd love to have you.
Excellent. Yeah, I'll start dropping by.
When yeah, when is that like 1 o'clock or something on Mondays?
Let me look at my calendar. Let me see. Let's look. Data science, it's at 11 a.m. to 12:30 p.m. Pacific. And
12:30 p.m.
I can Google the translation of that. Let's go 11 a.m. Seattle. Oops. To UTC. 7 p.m. UTC.
Yeah, okay. Yeah, that's kind of a goofy time for me, but I jumped in just a little bit late into that one.
Where are you at, YGG?
Oh, I'm nearby. Are you in Seattle or?
I am.
Yeah, I'm on Vancouver Island.
Oh, nice, nice. Will they let us in there? I need a passport, don't I?
At this point, well, you need some sort of passport, yeah. uh, yeah.
Yeah.
Or, I don't know, maybe just a driver's license. That might work. I don't know how the
Yeah.
border's doing these days.
Right.
But I'm sure you could sneak in somehow if you have the will. There's a way.
Dang, I was hoping my Discord handle would be enough.
There you go. Yeah, they'd be like, yeah, let
Bright
him in.
ID. Here's my bright ID.
That's right.
There you go.
Scan it. It's me. Excellent. Well, it looks like we're getting people fabs.
Awesome. Oh, hey everyone. Ah, Danilo, nice to see you.
Hey Charles. Here I am.
So I usually just give a few minutes for people to stumble in. Usually people are a few minutes late, so I usually just start with casual chat at the beginning. It's pretty good. And I'm usually doing some last minute prep, so that's what you can see on my screen here. And I'll always guide everyone, so the best way to get started with this stuff is just jump in the TEC Labs channel here in TE Commons and check the pinned messages, and you'll see a link to the Notion workspace there. And from there, what I'd like everyone to do is open up the attendance sheet. And I'll create a new column here. And I'll just make sure. Oh yeah, I'm also recording and also streaming, by the way. So if anyone has any concerns about that, just let me know. You can even direct message me. Let's see. Insert left. Lab 7. Okay, so if what we usually do is you can grab any sort of emoji that you like. And just if you're new to the labs, just go ahead and add a new row here. And the data is optional. Fill in any sort of columns that you would like to. And you can pop your favorite emoji or how you're feeling today in the Lab 7 column.
I see somebody sassy's got the latest Ubuntu 2004 there. Nice.
Oh, you got to upgrade.
Yeah. I need to get a new machine. I'm on an old HP that I enjoy, but
Yeah, there's 18.04 was a slightly unstable version because they were transitioning. I think that was the first LTS that moved over to GNOME. So it was a little bit, I think the 20.04 has they tightened up a lot of things. It's a smoother experience.
Oh, is it? Well,
Yeah.
that's encouraging to hear. I don't want to risk breaking my machine, so.
Yeah. Hopefully you can get a new machine. Maybe put in a proposal because you do so much for the communities. Maybe you could get a machine funded.
Oh, I didn't even think of that. I mean, I'd take like a redone machine. I don't need a new one. Let me
I wonder
see.
if we could have like a DAO asset inventory, like a database of all our computers or something. And you know, if we have things that we're not using, we might be able to send them around.
Oh, that would be so cool. I know I was thinking about that, and then I'm here in Seattle. There's got to be used machines somewhere. Where I was in Alaska, all the homeschool programs had like new computers, and like every student got a computer and every parent got a computer. So they always you could always get good used computers like really cheap.
That's so
You know, so
cool.
that it was really cool. But no mas, no mas. I gotta figure out how to get an emoji in here. I'm just gonna say ponies because I'm on my computer and I don't know how to do it.
Oh, I always just go, I open up a new tab and I go getemoji.com. And then there's all these emojis and you can just copy one.
Oh, cool. I didn't even know about that. That's gonna make my whole experience a lot more fun. Oh, look at that. Look at that.
Okay, so while everyone's stumbling in, I'll just, probably a few more people have joined, so I'm just going to say, to get started, you want to open up the Tech Labs channel in the TE Commons section here in Discord, and check the pinned messages, and you'll see a link to the Notion workspace, and that should be everything. From there, you should be able to find everything that we're going through. Open up the attendance sheet and pop in an emoji. You can use getemoji.com to find one, and at the top here we have the GitHub repository that we're going to be working in, and in the calendar you'll see Lab 7, that's the workspace. So I just put in the agenda here. It's a rough agenda. Hopefully by the goal by the end of this is we have this directory of a clean TEC hatch dashboard Python module that we can then import into Jupyter Notebooks and get some very cool widgets where we can tweak the parameters. We can get a visualizations of what those parameters mean. And this is like a prototype for a thing that we can invite everyone, the whole community, in to repeat the process that we're going to try to create today. And so everyone can create their own hatch version, their own parameterized hatch with the graphs that come with that. And then the community as a whole can vote on those outcomes. So pretty ambitious. We'll see how far we can get through this. Actually, this first one, I have to give a shout out to Danilo, because I'm always working in Jupyter Notebooks, but seeing the lab, the interactive Gitcoin modeling on Wednesday, I realized, oh yeah, it's good to go to like modularize your code and move it into like Visual Studio and create some clean functions and packages. So that's luckily what we've been working on is in a good state and it's ready for that. So if we open up the GitHub Labs repository.
So real quickly, where am I finding that link again? I got lost in the emojis.
Yeah. So you probably have the Notion workspace open?
Yes.
Good. So the GitHub is at the top. It's the TEC bookmark.
Oh, right, where it says master repository.
Yeah.
Got it. Thank you so much.
Oh yeah, no problem. If you have questions, probably 3 other people have the same questions. So good. So everyone, if you want to follow along, sometimes these labs start moving kind of fast, so they become hard to follow along. You know, we'll have different. Yeah. Is that Tonga there, or is someone? Phil. Hey Phil, I think your mic is a little robotic.
Oh, sorry, my headphones. But I go mute.
So we're on lab 7, right?
Yes, lab 7. So I'm gonna open up my terminal. And so you can git clone the, oops. So I always run this function essentials. It helps my, it actually speeds up my keyboard a little bit. And then, yeah, you can clone the repo if you want to follow along. I already have it here, so I'm going to go in there, TEC Labs, and I can, let's see, so I activate my virtual environment, TEC, doesn't exist, I think it's uppercase, okay. Now I use tmux to split my terminal like this, And I want to do someday I want to do like a session on just sort of terminal workflow, but not today. So I'm gonna go ahead and open up Jupyter Lab.
Is the TEC contained in the repo you cloned, or is that your own virtual environment that you already have set up?
It's my own virtual environment. So in Python, it would be like you use the venv package, virtual environment. And I think it's on the, if we check out the repo here, it's here. So if you want to create a virtual environment, we have all the instructions here. And then I use an alternative shell in my terminal here. I use the fish shell. And it makes, and then I use virtual fish, so it's really easy commands to create virtual environments.
Excellent.
Yeah, that's all here in the README. So everyone, you guys can check that out. Definitely, I recommend reading through this before, after the labs, or during. And yeah, so we've got our Jupyter Lab going. Now I've navigated into Lab 7. Also, a little tip that I do here is I have this scratch directory, and this is ignored by our git ignore file. So you can, this can be a nice like personal workspace. You can put anything in here, and it's not going to be tracked by Git. So it's like your local experimental workspace. And what I do locally, I keep a lot of repositories that I use, like HoloViews. And HoloViews is a nice repository because it has all these examples. And in fact, all of its documentation is built out in Jupyter Notebooks. So I can go ahead and open all these as references and just run them to remember how these libraries work. And so I'm not sure what this one's about. I'm not going to... Oh, it's explaining how HoloViews layouts are composed, so this is pretty cool. But let's not go down that rabbit hole. Just the concept that you can put anything in that scratch directory, and it's not going to get pushed upstream to the GitHub. So I'm going to go into Lab 7, and I was like trying so many things here, so I'm going to find the first thing we'll do is maybe just clean this up a little bit. So I think the good copy is not the one that's called good copy, it's the one that's called culture tribute 1. So here we have something missing. That might not be the good copy. I'm just going to go through these one by one. This seems like probably a lot of code and kind of overwhelming, and honestly it is. So that's why the first thing we're going to do today is move this code out of the Jupyter Notebook environment and into a actual modularized code base. And so what we have here is we're loading in some data sets. This is the impact hour data set in two different forms. So this is by user, and then this is like aggregate by period. This is the CStack token holders, because in order to participate in the TEC hatch, you have to hold CStack tokens. So it's an important, I'm pretty sure one of these is a good copy that everything should run. And if not, then we're going to have to do some tinkering to see why something's not working here. Okay, I think it was this cultural tribute one. What was this error we got? Dandelion voting, missing one required positional argument. I wonder if I can increase my font. Can you guys see the text here?
Yeah, I was gonna ask,
Sure,
can you bump
yeah.
that up a little bit? That's better, thank you.
I think it's lagging a little bit because of all these visualizations. Okay. Now it's just going to keep increasing in size because I hit the button too many times.
Nice.
Okay, that should do it. That's probably a little bit excessive. But let's see if we can. So missing an initialization parameter. What, dandelion voting. So we
I
have
think that there is a total there.
total
That should be
tokens.
the-
So I think I'm getting total tokens from our impact hours formula.
I
And
think that there is a piece of code that is missing. So
I think it goes here. Oops, I have to copy that.
and underscore, and it should be total tokens.
In the initializer here, I think.
No. I think that it's in the
Oops.
initial function, in the first function
In here?
here,
Yeah.
in the third one,
Oh,
total.
weird. Okay, and then we're also gonna need that because that's missing in the initializer or the constructor. I mean, so I have to total. No, these are impact hours. Where did I get total tokens from? Total C stack tokens. Let's see here. This is a lot to take in all at once. I've been hacking on this throughout the week, and I should have probably done a refresher myself before doing this lab, but let's see. How can we get total tokens? So it's this, what we see here is the hatch. So we're talking about total C-stack tokens, hatch oracle ratio, maximum raise, minimum raise, target raise, hatch period days, hatch exchange rate, and the hatch tribute. And somehow from that, I believe, I was getting, I might have a further iteration of this. This is called good copy, total impact hours. I definitely had a version that was outputting the... Let me try recloning the repository because I'm pretty sure I pushed all my changes. Or let's see the latest commit. So you can see my latest commit. It's been a lot of hack and slash, but this is looking really good. So I remember pushing a good copy. So the changed files, even though they're Jupyter notebooks, we can see that they were the good copy and the cultural tribute 1. So let's investigate those two files in particular. And I'm just going to reclone the repository because it's possible that I had like been working in some different workspace. So I'm just going to create something.
What if we have its status to see if it's ahead or not?
Oh, thank you. Yes. Yes. Okay, so there's a whole bunch. So let's just go for now. I could get stash to, let's also check that our latest commit here. Yep, I have the same latest commit. So I've made changes since the latest commit on my local system. And so I could get stash, and I think I'll do that. So I'm going to actually close this notebook and get stash. Now this brings me to, so I have it in my terminal. You can see that I'm now, if I do get status, it says you're all up to date with origin main, which is the upstream here. So let's try this again, Jupyter Lab. And remember from our commit, what were those two files? They were like cultural tribute 1 and good copy. So cultural tribute 1 and good copy. And I'm pretty sure this is the one I was working on. So let's go through this a little bit slower. So this is loading the data. So we have our impact hours panel that comes first. So this is modeling. Okay, so it's loading a couple data sets, historic and optimistic. This is actually the real impact hour data. We have this parameter, which is predicted hours. Okay, so let's just walk through this first of all. So what I've done here is we have our impact hours accumulation curve. So this is the accumulation of impact hours, the aggregate impact hours that the TEC has been accumulating through the praise system. So whenever someone is praised, it gets logged into a database and gets translated into impact hours. So as of January 15th, there was just over 3,500 impact hours accumulated. And if we continue that trajectory, so it was this kind of somewhat exponential trajectory, and Griff actually did this modeling. So what we have in blue here is actually the predicted continuation of the impact hours based on the historic trajectory. Now, we had this idea in the TEC that optimally we don't want our impact hours to grow exponentially. It would actually be better if they grow linearly. I mean, the less impact hours there are, the higher the hourly wage that people are going to get paid out through the cultural tribute. So we made this sort of optimistic projection as well. And this says that by the time of the hatch, if the hatch is in April, then we'll have 6,363 impact hours total. And then what I did is I made this orange line, which is the predicted. So it says if we kind of strive for this optimistic case, but reality says we're more likely to go for this historic case, then maybe we'll land somewhere in the middle. And so that's what I give the user this option to play with, and this is the predicted impact hours. So it's simply a slider. It's like a factor multiple that says how the impact hours are going to grow over time. Are we going to go just completely, the same as we've been going on the same trajectory? Are we going to strive to kind of, slim down our impact hours and have less total? Or maybe we'll even almost stagnate our impact hours and barely grow them. Or maybe they'll grow exponentially out of out of control. And then so this is nice. You can see here that the total impact hours. And so this number is going to really come in handy as we go later, because this can be used to calculate based on our total raise and our cultural tribute that we decide upon, actually how much DAI per hour everybody's getting paid. And since we already have the impact hour data, we can translate that to total DAI that people are going to get paid out from this cultural tribute. So I think that can be a really good kind of morale boost for people who have been putting in a lot of work, like Sem. He's #1 on the leaderboard. A lot of hours seriously coming from Sem, but everyone's been really putting in a lot of work. So it'll be really rewarding to get to translate this into actually what does that mean? What is the payout? So now that we have this predicted impact hours, we're going to move into the impact hours formula. And this is just some beautiful math that no one saw coming. It's really elegant. Sem and Griff figured this out together. And so it takes in this number. Okay, what are the total impact hours that have been accumulated? What's our minimum raise that if we don't raise that amount of funding, we're actually going to abort and refund the funds? Okay, and then as a person going through this dashboard as a hatcher, what is your expected what do you think for every hour that we contribute as an impact hour, how much can we raise? So the default for that is 25. So for every hour that any of us put in, we expect to increase the total raise by 25 DAI, or X DAI, or wrapped X DAI. What's the maximum impact hour rate? So what is, if we raised like 100 million X DAI, that might mean we're paying out our hatchers like 1,000 X DAI per hour. And we just all want to acknowledge that, well, that's probably not necessary. We don't have to get paid out 1,000 X DAI per hour. Let's cap it. So the default on it is 100. And then we have a target raise and a maximum raise. And the target raise is what we're hoping for. The maximum raise is actually a cap that's built into the smart contracts. So if we hit the maximum raise, then the raise is essentially over. So we can take a look at what this means. So we have our total impact hours, which gets populated from our projections in the previous example. And we do that but with this simple initialization. So in our init function, we take in total impact hours, and we just access our impact hours data, which I had just called I in this case. And this is a panel object, and so it's going to have this attribute called total impact hours. So this is using the param library, and this is really neat because if this is a param, and you can see that by these classes inherit from param.parameterized, and when we give them their attributes, we use this param module. So we say like total impact hours is a param number. And what that does is when we access this attribute from our object, we're actually just returned an integer. This is just a plain old integer. But because we've inherited from the param object, there's some really intelligent things that happen behind the scenes. There's another attribute called .param, and it's going to have, it's basically like an object or a dictionary that has this total impact hours. So this would be a different way to access this same attribute, but in this case, we're not accessing an integer, we're actually accessing a param number, which comes with all these bonuses, like it gives us these widgets. It basically knows how to visualize itself. And so what the param library does is it fools you. It maintains this plain integer, but whenever you try to access it, it has these access functions, getters and setters, that mean you're not actually directly manipulating the integer itself. You're interfacing with this piece, which is a parameterized number. So it feels like you're just accessing this number, but you get all this free functionality like the visualizations. Anyways, we're going to use this integer to populate our impact hours formula to get the total impact hours. So let's go through this, and then we just use our panel library to make this dashboard. So we have our total impact hours that's seeded from our previous, and I think we're going to go off course. We might get to where I planned, which is we export this code out into a module, but I think this is totally valuable just going over this alone. And we saw at the very end there was something that was broken, so I think we have to do this anyways to fix our code. So this is working out well, I think. So we have all of our parameters here: minimum raise, expected raise per impact hour, maximum impact hour rate, etc. And we get this chart here. So this is from SEM's formula, and it says the more we raise, the more we should get paid out per impact hour. So as you go up on the x-axis, you go up on the y-axis, but it has this asymptotic limit, which is exactly our maximum impact hour rate. So if we increase our maximum impact hour rate, we can see that the y-axis is growing, and the plot looks the same, but the y-axis is growing. So we could turn our maximum impact hour rate, and this is going to grow slowly. Okay, so it actually gets capped there because we have our maximum raise. I would guess, is that our maximum raise? Okay, so this widget's kind of funny because these things are like all intertwined, but basically we can turn our maximum raise all the way up to 1.8 million, and there's a way to actually increase that cap. I think it's like if we increase our expected raise per impact hour, what happens? So we have two like crosshairs here. So, and I was working on putting a legend in. I feel like I had it, but I made it required some sacrifices of other simplicity. And in blue here we have our expected raise based on this expected raise per impact hour. So that's simply a multiplication of this number times our total impact hours. But then the red crosshair is we have our target. So regardless of what's the expectation based on these kind of inputs, we also have the freedom to say, well, what should we strive for? What is the target that we're aiming for? And so if we set our maximum impact hour rate to something, I think 100 is pretty reasonable, and we set a target raise to let's see, what is this, around 500,000 DAI, then we get this impact hour rate, target impact hour rate is around 65 DAI per hour, with a target raise of just over 500,000. So we can play with this, and there's totally another chart here that's off. So maybe I can change this from, I can use this panel functionality, so I can go panel.column. This is a lot like Bootstrap. The panel library is a lot like Bootstrap. That's where I'm familiar with working with like this row and column format. So I just added this panel.column. So now I get these two charts in a column. And the beautiful thing about the HoloViz and panel stack is like everything's composable. So all of these visualizations are independent, and we can just throw them together and kind of loop them together really easily using this parameter inheritance system. And if you want to get a deep dive into that, just check out right here from the lab workspace, check out the lab playlist, and you can see lab 6, we go into a deep dive on panel. And so here we have actually the expected and target funding pools. So we have the minimum, we have the expected, and we have the target. And something that's really interesting for me that jumps out is like this, the cultural tribute seems huge. So there might be a bug in the code, or this might be just an unexpected outcome of the parameter setup, because I think usually we're thinking in our data, and we could do some further data science to really get to the bottom of this and even visualize it. But in our data that we were playing with to come up with these models, I think the cultural tribute was usually between like 1 to 20% of the raise. But what we see here, based on the conditions, it's looking like, maybe these colors are inverted. So that could require some, that would actually make a lot of sense. But I had checked that, I thought of that and I checked it, and it seemed like, nope, these colors are not inverted, this is correct. But these should essentially be the opposite. The cultural tribute should be rather small, like a maximum of 20% of the total funding, and the funding pool should be the majority. But let's take a look at if we say, what's our expected raise? So as we increase our expected raise per impact hour, we see that there's more funds going towards the funding pool, especially in that expected section. And if we increase our target raise, our total target raise, then this starts to grow. Now, as we increase our raise, we start getting the properties that we would hope for, which is the cultural tribute being a smaller and smaller portion. So this is this sort of incentive aligned aspect that we pin down to the cultural tribute, where the more funds we raise, the more the hatchers will get paid. So if the amount of funds raises anything, then the hourly rate of the hatchers will also increase. Yet at the same time, while that constraint holds, there's another constraint that says the more we raise, the less the piece of the pie goes to the cultural tribute. So this is a double incentive. It means for the hatchers, the more we raise, the more we're going to get paid per hour. But also for the investors, or the co-vestors we like to call them, the more they invest, the larger the piece of the pie they're getting. Because the pie is growing, which helps the hatchers get a larger payout, but the piece of the pie that goes to the hatchers is actually shrinking as the pie increases, so the co-investors get a larger piece of the pie as they invest more. So it's this like doubly incentive aligned way of maximizing the amount of funds that we want to raise. So I think this is going to be a really fun dashboard for hatchers to play around with, and it's very dynamic. You can get into weird kind of situations depending on how you play with this thing. Yeah, you can get into these, like, you can like basically break it, which makes sense if the maximum impact hour rate is 0. Okay, that makes sense. So let's not get too stuck on that. Now let's keep moving on. And so this is sort of setting the expectations, and this is actually how the final impact hour rate is going to be determined. It's based on our expectations. This is a key input into the smart contracts: expected raise per impact hour and maximum impact hour rate. These two attributes actually go right into the smart contracts and determine how much people are going to get paid out. And then the third variable that plays a role is the total impact hours. Oh yeah, and then the fourth would be the total raise. So the things we can control are these two parameters. We get to actually tune these for the smart contracts. Now this, we don't really get to tune, but we get to kind of guide it. We can sort of guide how many impact hours we want to accumulate. But by the time we launch the DAO, this will be absolutely determined. It'll be fixed. And then there's a fourth variable that will determine our impact hour rate, and that will be unknown at the time of the launch, and that is how much we raise. It's the total raise. So we can only speculate on here, and that's what we're doing with our target and our expected. So really interesting dynamics going on here. There's a whole blog post on this. I think it's linked here, and I definitely recommend people play around with it. There's a whole nother math widget that actually exposes even more sort of parameters and windows into how this is working, and I really encourage people to play around with it here. So maybe I'll just drop the link to this forum post in the TEC Labs channel. Okay, so that's the impact hours formula. Now we get to the actual hatch. And total target TEC tokens. I think this is what okay, so total target TEC tokens. I think that's what's going to get set in the initializer. Oh, we don't have an init function. Okay, no, it's the next one that was had that issue. So let's check this out. So this is the actual hatch. Now this might look scary at first, so let's walk through it. So this is a fixed parameter. This is the total CStack tokens. Now keep in mind, only CStack token holders are allowed to participate in the initial phase 1. The whole TEC is going through 2 phases. Phase 1 is the hatch, and then phase 2 is the initialization of the bonding curve and the conviction voting. And so what we're doing with our initial hatch is we're going to initialize a dandelion voting DAO. And this is like the God mode of the DAO. It can override any parameters of the DAO. So we have to be very careful with how we tune this at the beginning. And we're going to use this mechanism, the dandelion voting, to vote on all the parameters of launching phase 2, which will be the bonding curve and the conviction voting. And then from that point on, after phase 2, most decisions will all be made using conviction voting. Unless we really need to augment the DAO for some reason at some point in the future, then we will have this dandelion voting mechanism to do that. So this is total CStack token total tokens. Now this number gets multiplied by this number to give us a total possible raise, because what this is saying is if you hold 1 CStack token, you're allowed to invest 1/100th of wrapped XDAI in the hatch. So this is a multiple on your CStack tokens that you're allowed to invest. So we could turn this right up. It could say if you have 1 CStack token, you're allowed to invest 100 XDAI or wrapped XDAI per CStack token. And what you can see here, it changes the y-axis. So if 1 CStack token means you can invest 1 XDAI cent, then the total possible raise, if every CStack token holder invested their maximum possible capacity, then the max we could raise would be just over 400 XDAI. And this is the kind of thing, because we're actually doing a dress rehearsal, a test tech hatch soon, coming up in the next few weeks. So this is actually the kind of range that we want to work with in that case. So if for the test hatch, this is a realistic number, but for the actual hatch, it might be between, maybe 10 is reasonable. That means that gives us an 800,000 cap. Okay, maybe 20. So this is a really interesting one to play with. It changes the maximum possible amount we could raise during the hatch. Now keep in mind there's also the bonding curve coming in phase 2. So this isn't the complete picture of funds being raised for the Token Engineering Commons. So there's that hatch oracle ratio that we can play with. Now this drove me crazy. I spent a lot of time thinking about this because it seems weird. We have these same parameters showing up again. We had maximum raise and minimum raise in our previous dashboard here. And I struggled so hard to like unify these and only have these in one place, but I eventually came to the conclusion that it does make sense to repeat those parameters. So we have them here. We have our maximum raise and our minimum raise as part of our impact hours formula. We're also going to have them here for our hatch visualization, but they're different. In this case, they're not absolute amounts of xDai. They're actually relative amounts from 0 to 1 of like, or in this case 0.5 to 1, and it's saying, what happens if we hit our max capacity? What happens if we hit the maximum raise possible, or if we only hit half of it? And so now I'll explain what you're seeing here in this chart. So we have in blue the maximum possible raise, and what this is it's actually a distribution of the C-stack token holders. So in a ranked view, from most tokens held to least tokens held. So this index 0 on the x-axis is the person, I think it's Griff Green, maybe he's in this call right now, I'm not sure, but Griff Green probably has the, yep, so this is him here. So this, we can see how much Griff can actually invest in this hatch. And so if we turn this all the way down, oh yeah, this isn't a total raise, this is actually per person, I believe, this index. So if we turn this all the way down to 0.01, then Griff can invest up to 400, just over 400 wrapped xDai into the hatch, or the test hatch. And as we turn that up, it increases. Yeah, I kind of forget actually what this axis is, if it's per person or if it's total. It would make more sense if it's per person, because on the x-axis we have per person. But anyways, let's keep going. So we have the cap raise. Now the orange is our expectation of like, okay, do we expect only half of the C-stack tokens to invest, or do we expect all of them to invest? And then, or somewhere in between, and we can slide that range. And what we see down here is there's some of these numbers are changing. So the max goal is changing. So if 100% of the C-stack token holders invested as much as they could, then we get this case here, where there would be a total of 7,120 xDai staked. And this is, I think this is pretty clever. I took the geometric mean. Or okay, let's just forget geometric. Let's think about the mean. This means your average C-stack token holder has to invest 28 xDai. Okay? And then that would get us to this case. But this is not just the mean, it's actually the geometric mean, which means you're going to have a distribution of some people investing 10 times this amount and some people investing 1/10 this amount. So it's like an order of magnitude average. So this would essentially be the middle of this, because this is like you can see this is a power distribution. This like grows exponentially or diminishes logarithmically. And so the middle point is going to be this geometric mean. And so the people with the geometric average of C-stack tokens are expected to invest about 28 xDai in this case. And Griff Green would be expected to invest 10 times that, which would be around the 280 mark. The exact amount in this case is 800, but following the geometric, because he'd be at the end of that, just the very end of that distribution. So a lot of these people would be expected to invest around 280 xDai, and a lot of these people would be expected to invest around 2.8 xDai, and then we get the geometric mean in the middle. And then we also get the hatch tribute. I think there's another. Is there another hidden visualization here, or did I not render it? Let's see. Yes, so we have another. So let's change that into a column as well. So we have this. I think I just have to try changing this into a column. Yes. Okay, so then we can't quite see the table. There's always trade-offs. So let's keep looking at that. We get the. We're already. I think for this whole hour, I'm just gonna go through this notebook. I think we're already on that trajectory, so that's okay. And we'll get this all modular later. So we have the XDAI funding pool. Cool. So we have the total XDAI staked, and that gets broken into two categories, which is the hatch tribute and the funding pool. So these two numbers would sum to be the total XDAI staked. And so in this case, with these parameters, where we reach our max capacity goal, we're going to have 133 XDAI in the hatch tribute. So this is going towards, let's see, where does the hatch tribute go, Griff? Towards the pool for public token engineering goods?
Yeah. So the hatch tribute, the main thing here for the hatch tribute is that it's non-redeemable. So when during the hatch, the people who put funds in, there's like two tributes. There's the cultural build tribute, and then there's the hatch tribute, and they can pull out their share of funds that aren't in the hatch tribute. So when you upgrade to a commons, you'll be able to choose to add more funds to the other to the conviction voting pool if you'd like. So because the commons upgrade, you can send money different places. So it really, the biggest impact is on how much you can redeem as a token.
Yeah.
So there's two vaults basically. There's a vault you can redeem from and a vault that you can't.
And I guess that plays into this next section, which is going to have this the rage quit hours. Is that sort of the... I don't want to spoil this next section because it's the juiciest part. But essentially, hatchers have the opportunity to pull out of the hatch. But save for this hatch tribute. If you invest in this hatch and then later you decide, no, this isn't for me, I want to take my money back, well, the hatch tribute is it's non-redeemable. And what's cool here is, at the end of the day, these things, it doesn't matter how many tokens there are because it can always just be normalized, but it's fun anyways. So in this case, if we hit our max goal, then we're going to have a total TEC tokens of 26 million. 26 million TEC tokens. So and I think we can change that based on how much that's based on how much we raise. So I'm going to change this back to a row so we can see that table.
There's also the hatch exchange rate, which changes.
Oh yeah, that's totally gonna, yeah. So maybe people want more tokens. And this is all the hatch exchange rate does. So, and like in theory, in all the math, this should never affect anything. It shouldn't change the outcome. It shouldn't change the amount raised. It shouldn't change anything. It's just going to change the number of tokens and the price per token. But in practice, we know that humans are really sensitive to numbers and what they look like. So in practice, I would imagine this would actually be very important and will change the outcomes. So it's going to be a fun. This isn't going to change how any of the visualizations look, but still, we encourage people, the hatchers, as they're playing with these parameters, put some thought into this, because even though it doesn't change the plots and the numbers here, it probably will change the total end result and the outcome. So it'll be interesting to see what people choose for this exchange rate. Oh yeah, and then the hatch tribute here. So we could turn that way up, and that will change these visualizations over here. So we could put the majority as a non-redeemable lockup, but that's probably not a good idea because it might be kind of scary for the investors. So 5% is the reasonable starting place for that. And I think I have to change that parameter a little bit. I'm going to change the step. Yeah, I'm going to add a step to this. Step equals 0.01. And then it's more granular. So this is the hatch view. This is probably the hardest one to grok. I recommend everyone just stare at this for a while. I think it'll start to make sense if you really read through these headers here and what is the outcome. And just keep in mind that this is CStack token holders, and this is the amount that they stake per holder. And yeah, I've answered my own question that I had earlier. This is per holder because we see that the total raise is like, you know, the cap raise here in this case is 3,560. So for any like calculus nerds, this number would be the area under this blue plot, this like the area of the blue. So you could kind of do an integral. And you could even like for future, to generalize this to all DAO hatches, this could actually be like a probability distribution. In this case, it's real live data. But this, to generalize this to a theoretical DAOs, this could just be a probability distribution. So that's cool. That's the hatch. And let's see. This is my favorite one. I think this is so cool. The dandelion voting. So we're going to have total tokens, which we get from, now we want to populate from here. But I've filled this in with a default of 6 million. Maybe I'll fill it in. Well, let's see what the default is when I run this. I think it should have default parameters, and our target goal is actually 17 million. So I'm going to change this to 17 million as the default, and let's run this. And I can take away this, or I can set this so total tokens, and I can pass in an initializer the same that is the default anyways, but I'll just pass 17 E6, which is 17 million. Constant parameter, total tokens cannot be modified. Yeah, so I'm trying to... Oh, that's because I have this constant thing here. Let's just take that out. Okay. It works. Now we can actually change this. Let's see if it's reactive. So if I put 100,000. Okay, so it changes the axes. So that's cool. So same thing like I was saying before. This like total number of tokens doesn't actually change. Like it won't change how this plot looks. It's just going to change the axes here. So let's turn that back to the default. 17 million. Now this is fun. This is like finally we can understand support required and minimum quorum for dandelion voting. And it took me, I made so many really inaccurate visualizations that didn't make any sense until finally I worked with Griff and Jake a lot on this, which helped so much. I wouldn't have been able to figure this out on my own. So we can change this minimum support. So what minimum support is it's the percentage of token votes that must vote yes to pass a proposal. And so what we see here is like as we grow the number of tokens that have voted, the amount that have to vote yes, which is this line. So the important thing to consider is this boundary line between red and green, because that is the boundary between a vote passing and a vote failing. And I want to do, there's a few future projects here that maybe some of you are imagining already, and I can definitely imagine some. We could actually now run a simulation with this, and what a vote would look like is a vote would be a line, a curve that we could superimpose on this plot, and it would grow. As more people vote, the curve would grow on the x-axis, it would move to the right, and as people vote, oh, this should be, this might be a bit confusing, token parity. I think this could just say yes votes. As the number of people who vote yes goes up, the curve would go upwards. So how a vote gets passed is, first of all, let's check out this minimum quorum, and I'll explain that in a second. But first of all, the number of tokens would have to surpass this blue threshold to simply be eligible. That's the minimum quorum accepted. It means we need at least 12% of all tokens to vote yes. And this is a very subtle detail that's like really confusing too. And it makes total sense if you like really flesh this stuff out and think about it. It makes sense, and it's an improvement on past Dandelion implementations. But we want this minimum accepted quorum to be the percentage of all tokens that have voted yes. So this means 12% of all tokens need to vote yes on this proposal in order for it to pass. That's a hard constraint. And so in order to do that, it means we have to be in this green area. So if we're in this green area, it means we have surpassed minimum accepted quorum, and we have surpassed minimum support. It's actually possible, this visualization could be a little bit deceptive because it's possible that we're like way over here on this chart, like a whole bunch of tokens have voted, and we're not even past minimum quorum, because minimum quorum, like I said, is total tokens that have voted yes. So when someone votes no, it does not contribute to the quorum. It does not increase the quorum towards this threshold. So we could be like way over here on this chart and not even past minimum quorum. But if we're anywhere in this green area, then it means we know that we have indeed passed minimum quorum, and we have indeed passed the support required. So what we could do, we could play out a simulation where we see this curve grow over time, and it would kind of wave, like a very controversial vote would actually dip into the passing, and then maybe people would come to block it, so it would dip into the red, and then people would show up to pass it, so it would dip into the green, and then people would show up to block it, and it would pass into the red, and it would be like a football game or a U.S. election, you know. You'd have to get your popcorn out and you encourage all your fellow hatchers to vote. And in that sort of simulation, see, there's some parameters here that are not being visualized yet. So we have the vote duration days, which is, I guess the default here, I put 3. I think I need to go through this and update all my defaults to match the TEC spec. So that's one thing to be done. But vote duration day, maybe it's 3, maybe it's 7. This means a vote can only, and I'm gonna go through these. I might get some of them wrong, and Griff, you can kind of jump in maybe at the end. Oh, we only have 4 minutes left. I apologize, but also I think this is good stuff. Sets the foundation for the next iterations of this. But vote duration is like the total number of days that we have to vote. So it would be a 7-day simulation that we could run on a vote moving through this space. The vote buffer hours, it means if we initialize a vote, we can't initialize any more votes for at least 8 hours. So we can have votes running in parallel at the same time, but we can't like start 2 votes at the same time. We can't start, or unless we turn this to 0, or okay, minimum looks like it's 1. So if we start a vote, we definitely can't start another vote for at least 1 hour. So we can't just spam votes. And that ties in, I'll skip this one for a moment, tollgate fee. So this is the cost per vote initialization. So if we say, hey, I know I got all the right parameters to launch the bonding curve and conviction voting, and I'm going to put a proposal forward, well, you need to at least stake some XDAI to show that you're serious about that proposal. So I think the default is 3. I think it's pretty reasonable, but this goes all the way up to 100. Maybe we want it to be very expensive to propose a vote, and that this requires people to put in a lot of thought. I think this is a very important parameter to consider. And then finally, the rage quit hours. That means it. Okay, so we've put forward the vote. We're upgrading the TEC, and it's gonna launch. It's actually passed. The vote has passed. Well, this creates a buffer of 24 hours, saying that vote, even though it passed, it's not going to be executed for 24 hours. And this connects back to what we were talking about before, the redeemability. Investors can pull out. They can say, okay, well, I didn't like that vote. I voted no. I'm not happy with the way this is going. They have 24 hours to redeem all of their initial investment and pull out. And I think that's a great opportunity. And this has a more formal name. We could rename this, but I really like this term, rage quit hours. It's so clear. And Griff, did I get any of that wrong? Is there anything that should be really corrected?
I don't want to say wrong, but there's always more details.
Yes,
right?
There's a lot more details. Yeah.
Nailed it. This is amazing. This is incredible. I mean, it looks done. It looks basically done. I assume you just want to do a couple more iterations, but
Well,
on top of
that's a good. So I'll go quickly. We got 2 more minutes. I'll go over what the next steps are. I want to pull all of this out, inspired by Danilo from the Wednesday lab. Awesome hacking on Gitcoin, and I encourage everyone to like stay tuned because these labs are expanding. It's really exciting. But the next step here is I want to pull all of this out. We have these nice classes. This is like really great. We should pull these out and put them into a Python module. So I would go like a new. Let's see, we can go like new file, rename, and I'm just going to call it like TechHatch. I was going to call it tech for TechHatch, tech.py, and then we can go in there, and basically we just want to copy all this code and take it out of the notebooks. And what that's going to give us is we're going to be able to make a new notebook that's super clean. We're just going to go from tech, import, impact hours, and then we'll go, display impact hours, and we'll get that whole visualization without any code, just this like 1 line of code. So it's going to give us a really clean interface, and then finally that will be basically done, that people can play around with it. Future iterations, there's things that could be improved, but this could be the test param vote for the test hatch basically. And I want to find a piece where I can export this as a PDF, so anyone can play around with these parameters, get the visualizations, and then just click a button at the end and it exports a PDF. And then it's really easy. Anyone can just read the PDF like straight from the GitHub repo. You can open up PDF files, and it would make the voting process very easy.
This is so incredible, and I really love the idea of making it a module, because other people will want to create Dandelion DAOs without any of the extra stuff. So if they have this, they can visualize what their requirements are for things to pass, and better understand what these pieces are. I mean, maybe eventually this could even get integrated into OneHive's deployment, so that when people are putting in, they see these graphs.
Exactly. Yeah, and I want to share with everyone that this is kind of the end of a series, or towards the end of a series. This has been about 4 labs that we've been collaboratively working on this. So if you want to really see the process of how this was built out, go check out the YouTube playlist for the tech labs. And shout out to Jake and Griff for Sunday Param sessions. That's where, and anyone's welcome. It's in the TEC calendar, so stop by on Sundays for some hack sessions on this sort of stuff. And we're a couple minutes over, so I want to thank everyone for coming out. And stay tuned. Lots more lab stuff happening Wednesdays and Thursdays. Check Twitter, I guess.
Yeah. Thanks, Sean.
Thanks, Phil. Get a new mic.
Thanks, John. That was incredible. Thank you so much.
Thanks, everyone.
Thanks, man.
Thank you.
Bye-bye.
Bye-bye.